Hi everybody, welcome to AppDuck channel. We create videos to help you make better apps. Today, I'm gonna show you how to make an onboarding screen in SwiftUI with infinite auto-scrolling carousel, and this is what you get by the end of this video. We can start with a brand new project. I have just created a new project earlier. It's best for you to prepare some images for the carousel. I have prepared 28 images in advance. I generated these photos using AI, and I've prepared some color extensions. You don't have to use the same color as me. You can pause the video if you would like to use the same color extension. Okay, let's begin by creating a new file called infinite carousel view. Okay, pretty good. I will start with creating a card UI. Assign frame. Okay. And give it a rounded corner of radius 16. Okay. Looks better. And let's add a little bit more shadow. Look pretty nice. Okay. Let's make it a subview by carousel card. We call it carousel card. Move it here. And change this to image name. Okay. Carousel card. Okay. And let's make 7 of them. I call it just I. Okay. And change the image name to string I. Okay, we have 7 images. But we need it to align horizontally. So I embed them in HStack. Looks better. And it's a scroll view. Okay. I have to change the axis to horizontal. Okay, pretty good. Remove the indicator. And you can see the shadow is clipped. So we will disable the clip. Okay, it's now good. And then let's adjust the spacing a bit. And give the carousel some content padding. Let's use safe area padding for the horizontal part. Okay. It looks a lot better now. The next thing we are gonna do is to make our carousel scroll automatically. And to make it scroll automatically, that means we must scroll our scroll wheel programmatically. To do that, we will use the new API called ScrollPosition. ScrollPosition. Okay, I will show you how to do that by using some simple example. I will wrap each card with a button. Give each one an ID of I, and when we touch each card, a card, we use the scroll position to scroll to our desired location. We can see the scroll position provides us a lot of methods to use. We can scroll to X to Y, to both X and Y, to point, or to ID of each item in our list. So I will show you by using the ID. Then when I tap on a card, nothing happens, because we have to assign to the scroll view that if you use this scroll position state, we'll use this modifier scroll position scroll. And then here we go. You can see when I tap the rabbit, our carousel moves a little. We can also assign anchor. See the center. I tap a rabbit and it moves to the center. Looks better now. We can add some animation, a spring with a snappy style. Then we tap on the rabbit, it moves smoothly and snappy. Great. Okay. This is how we use the scroll position. Then, okay, I'll remove some code. I remove the anchor and also remove the button. Now we know how to use the scroll position. Then, what we have to do is to move automatically. To do that, we must introduce two new states. The first one is a timer. And the second one is X. And then we listen to the timer. When the timer ticks, we will move X a little, and then we observe the change to X. If the X changes, we scroll to that position. Okay, for example, when timer ticks, I move X by 1, and then when X change, we scroll to that position. And voila! Our carousel moves automatically without any touching. Then, what we have to do next is to make our carousel move in the loop. Now you can see it ends. It just ends there. To make our carousel move indefinitely, here's the technique. What I will do is when the scroll wheel moves past all items, I will scroll back to the beginning without any animation. So it will look like the scroll wheel move infinitely. Let's see how. We add a condition for that. If x greater than or equal 100 plus 8 multiply by 7, we set the x back to 0. Otherwise, we increment x by 1. You see that? You can see the animation repeats itself, but it is not what we are looking for. We will fix it soon, but before that, let's take a look at the formula we have just done earlier. 100 is the width of each card. The 8 is the spacing between items. Okay, we can change it to item spacing. Okay. And the 7 is the number of items in our carousel. We can make our code more readable. Okay. Okay, and we will accept a image name array so we can change the items in our carousel later. Okay, we change our formula to be more readable, but there is some error. Okay, we have to assign the image names here. Okay, it looks good now. So let's move on to fix our problem. You can see the animation is not continuous. Why? Because this formula check if we move past all items or not. But what actually happened was our scroll wheel can only scroll past just 3 elements, not 7. So our logic was right, but if we can make the scroll view actually move past all elements instead of just 3, our formula will be right. To fix that, we must add buffers. What I mean by buffer is we will add the same element twice. Okay, and to do that, we have to create a new struct to hold each item. We say item. If we have ID and image name, you will see why soon. Okay, then let's make this private and create another property called items, and we have to create a custom initializers because in the init we will add the same image names to the item twice. This is how I do it. I create an empty array of items and I append the image names mapped to items twice, and then I assign back to the self.items, and then instead of iterating through image names, we iterate through items. And let's see. Do you see that? It looks better. It can move indefinitely. So our carousel is almost done. But if I will slow down the speed to show you something. Here, you can see the last element of our carousel just disappear like that, because when we scroll past all elements, we move it back to the beginning, which at the beginning we don't have any item on the left. So to do that, we have to add one more buffer, and we have to change the starting position of X. Let's duplicate this line, and to make our code nicer, I will add one more property, name Carousel length. I will calculate the length to use later. Okay, now we get the new starting position of X and the carousel length to use later. Then we have to make some changes. From here, this one is actually the carousel length. But from what I said earlier, these two lines, we have to make some changes. Because now our X start at the carousel length, not start at 0. So to check if we scroll past all items, we have to add one more carousel length to it, which is carousel length double. And if we scroll past all items, we set X back to carousel length, not 0. We can see now the last item doesn't disappear anymore. So it's all right. Soon, we would like to have our carousel move at a different speed and the direction. So we can adjust this value to make our carousel scroll faster or slower. But to make our carousel move in the opposite direction, we can use negative value. Let's say -2. The items now move from left to right, but now it just stops moving because our condition here only check for positive value, not the negative one. So we can add one more condition. And now it's all good. And to make our carousels move at a different speed and the direction, we can make this one a property. Let's call it velocity. With the default value of 1. Here. And we can just change the value here to velocity. Let's take a look when we have got more carousels. Let's create a new file called Onboarding view. Okay, we have 4 of them. And let's change some images. Now I think our carousels moves a bit too fast. So I will change the velocity to 0.5. Okay. By 4. Okay. Looks pretty good now. But there's one more thing. If I hold the first row, the other rows also stopped. And if I move and release, you will see that it didn't continue from where I start holding it. And we will fix that. To fix that, first, we need to detect when the scroll view is manually started or stopped. And the second one, we need to observe the distance the scroll view was moved during the period. Okay, and to do the first one, we need to use .on scroll phase change. Okay, let's see what it does. Okay, use this modifier to be informed of changes to a scroll view's phase. Okay, well, we better see that in action. Let's print out old phase and new phase. Let's bring the simulator in. Okay, I forgot to change the entry point. Okay, the entry point is still content view. Okay, let's copy the preview and place here and build again. Okay, it's good now. You'll see that if I don't do anything, it starts with idle and idle. If I swipe, you see, when I just started swiping, it changed from idle to interacting. And when I release my finger, it changed from interacting to decelerating. And when it's about to stop, it changed from decelerating to idle. If I just scroll slowly, you see? If I scroll slowly, it will change from idle to interacting when I started swiping, and when I release the finger, it changed directly from interacting to idle. Okay. With this, we conclude that if we don't do anything to the scroll view, it will be idle and idle, and we shouldn't do anything. And if we start interacting with the scroll view, the scroll phase will change to interacting, and we should stop the timer. And if we release the finger, it will change from any moving state. It might be interacting, it might be decelerating to idle, and on this state, we have to resume the timer. Okay, does that make sense? Repeat that again in code. Switch old phase and new phase. Okay, if is idle and idle, we don't do anything. And if is any state to interacting, we stop the timer. And if the scroll phase change from any moving state to idle, we resume the timer again. And for any other cases, we just don't do anything. Okay. Okay, now we are done for the on-scroll phase change modifier. We'll move to the next part. Now we need to observe the distance. To do that, we need on-scroll geometry change modifier. Okay. It might look a bit overwhelming, but let me explain. The first closure, let us observe the change in the scroll geometry, which might be its offset or its size. In our case, we need to observe the distance. We will type the scroll geometry here, and in this closure, we will return the property we need to observe, which is the distance, and we can get that by using dot content offset dot x. Okay, and since we only do one line, so we can omit the return keyword. Okay, and for here, we must type the type of the property we are observing, which is the type of x. Okay, show the quick help, and its type is double, and let's type it here. Okay, and the last closure is pretty simple. It notifies us when this property is changed. So, and it let us know the old value and the new value. So we only care for the new value. We set that to x. Okay. And let's run again. Now, if we move, and when I release, it's continue from where I pressed. Looks good. Let's get back to our onboarding view. Okay, now, okay, it looks better. But there's still an issue. If I hold on to one row, the other rows also stopped. And I think it's the issue with the timer. Okay, you must change the run loop from .default to .common. Here and here. And let's see again. Okay, hold on. I can hold on to one row, and the other rows can still move perfectly. Okay, Let's adjust our style a bit. We can add some background. Okay, and we can tilt our carousel a bit for more playful look. A bit too much. Okay, and we'll put it at the top. Alright, and we can overlay it with the gradient. Okay. And let's put some content here. Voila! Let's make our overlay a bit more white. And that's it. If you loved the video, please like and subscribe, and see you in the next one. Bye bye.